Hello, we are Team JJANC, and this is a prototype demonstration of our device. How this works is that once this bar is pushed down, it will push this T-rod forward, and this clamp will close. Once it's released, everything will turn back to its original position because of the springs. Finally, this knob here is able to control the precision of how far the clamp is able to close.
So today I'm going to go over some of the parts for our device. This is the button bar. We sketched and box extruded this, and this. After that, we cut extruded this part, the part in the back, and lastly, we cut extruded the hole right here, and then the bottom part right here. Let's move on to another part. This is the T-shaped bar. So we sketched and box extruded this part. After that, we sketch and box extruded a square and then cut the side of it. And lastly, we use fillet to give it a circular shape. Let's move on to our last part, the top clamp. For the clamp, we sketch and box extruded this part. After that, we use swip right here, and then we use fillet to give it a curvier shape. After that, we use cut extrude for the hole right here. So yeah, this is how we created some of the parts of our device.
This is the motion study that I created for this device. So these springs in real life are actually held in place with super glue.
These are our simulations. We use acrylic plastic for the T-rod and the button lever, and we use 304 stainless steel for the clamp. In all those simulations, we found that the yield strength was higher than the maximum bond meso stresses experienced. Therefore, the materials used and the design was sturdy enough to function properly. However, because we had to scale the device up due to manufacturing constraints, the actual materials would have to be much stronger due to the much smaller scale. Through using CSE EduPack and constraining the materials to be suitable for surgical and maximizing strength while minimizing cost and mass, we found that stainless steel, AISI 431, and PSU to be the most ideal.
Here we have a prototype of our device. Pressing the button closes the clamp, and the handle is ergonomic, making it easier to hold. And here we have the inner workings of our device. It is a bit difficult to close the clamp completely due to friction between the T-rod and the clamp. The knob can be used to adjust the length of the clamp when it is opened.
Throughout the process, we were able to collaborate and collectively design a device despite the challenging circumstances we are currently in. These are the sketches that we made together throughout the start of the design process using the shared whiteboard program. For inspiration, we researched other devices previously made and expanded upon those designs. We also learned the limitations of the 3D printer, scaling certain parts, curvature, and adjusting parts after making an assembly.